students. Today we'll start a new chapter, that is materials, metals and non-metal. So this is the last chapter and I will finish in 2 classes. Okay, so here mainly we will discuss physical properties in details and chemical properties, maximum 2 or 3 chemical properties we will discuss. Now first of all, you should know what is an element. These you have studied in your lower classes also. Just remember, you know what is a matter. Matter is anything which occupies space and has mass. Okay. Now, what is element? If you take the case of copper, elements are those substances, or element is that form of matter, you can say, which consists of same type of particles. Like this is copper. Let me say this is copper wire. Okay, now this copper wire consists of same type of particles. Here all these particles are copper particles. Okay, and here all these particles are called as atoms. Okay, all these particles are copper particles only. I can write Cu, all the particles are copper particles. So what is an element? Which consists of same type of particles. Like hydrogen, if you say, it consists of only hydrogen particles. Oxygen consists only of oxygen particles. Iron, which consists only of iron particles. Okay, now these generally we write COPPER. All the elements, they have symbols. Okay, so symbol of copper is this, symbol of iron is Fe, symbol of silver is Ag. Okay, so all the elements, they have symbols. Another definition is this. Now you know, first it's not a definition, actually what is an element? Which consists of same type of particles, called as atoms or molecules also. Okay, molecules are bigger in size than atoms. Now if this is copper, this cannot be broken into more smaller pieces. Okay, now what is compound? Now we say that water is a compound. Okay, now suppose this is water. Okay, let me say this is water. So this water, it also consists of large number of particles. Okay, it also consists of large number of particles, but here all the particles are water particles. Okay, all these particles are water particles, which are called as molecules. Why molecules? Because it consists here of 3 atoms, 2 atoms of hydrogen, 1 atom of oxygen. So total there are 3 atoms. So more than 1 atom, we call it as a molecule. Now this is water. If you will see, it consists of large number of particles called as water particles or molecules, but water is called as compound because it is made up of more than 1 element. So here if this is H2O, so it is made up of hydrogen element plus oxygen element. Understood? So it is made up of these 2 elements, hydrogen and oxygen elements. So hydrogen atoms and oxygen atoms have combined to form these water molecules. So but copper is made up of single only. Okay, and compound is made up of more than 1 different element. So if this is water, which is made up of more than 1 element, so this can be broken down into hydrogen plus oxygen, because this water is made up of hydrogen and oxygen elements. So it can be broken into these 2, but element cannot be further broken down. Okay, so that is what I want to say you. So these are some of the elements. You can underline hydrogen, helium, carbon, nitrogen, oxygen. Okay, you can see underline till mercury. Okay students, now this all I have explained. The smallest particle of an atom, obviously the smallest particle of an element is atom only. Okay, so this all I have explained you. Okay, now if I have told you about copper, in your book it's given sulfur. So sulfur is an element which is made up of large number of sulfur atoms or particles called as sulfur atoms. There are 92 naturally occurring elements known as known to us at present. Okay, now pay attention here, students. These elements are actually sorry, these elements are actually divided into three groups. Now you have to, an element, it is divided into three groups: metals, this side totally it's non-metals, and here it is metalloids. So there are 92 elements, and we cannot remember the properties of all the 92 elements. So these 92 elements are grouped into three groups. Here, and those three groups are metals, metalloids, and non-metals. Now in metals, all the elements, they have almost same physical and chemical properties. There may be one or two exceptions. In non-metals, all the elements will have same properties, okay, physical and chemical. But the properties of metals and non-metals are totally opposite. And in the middle, this metalloids, which have the property, whose properties are intermediate between those of metals and non-metals, are called metalloids. For example, metals are good conductors of electricity, whereas non-metals do not conduct electricity at all. But metalloids conduct electricity to some extent. So it has a metalloids have a intermediate properties. Understood or no? It's easy only. Now we will study. So please, I have explained you from here till here. This thing and this thing is same. Here it's given in short form, but I will explain you in detail. Okay, we will discuss the physical properties of metals and non-metals. As I told you, the properties of metals and non-metals are totally opposite. First is malleability. What does malleability means? Metals are malleable. Now students, if you take a piece of aluminium and if you will place it on a block of iron and beat it with a hammer, that aluminium will change into a sheet. Okay, that aluminium piece, metal, will turn into a thin aluminium sheet without breaking. It will not break. If you hammer it, it will change into a sheet, and this property of a metal changing into a sheet is called as malleability. Okay, malleability is an important characteristic property of metals. Most of the metals are malleable. Underline, gold and silver are the best malleable metals and can be hammered into a very fine sheets or foils. You have seen silver foil also, generally over the sweets. You have seen aluminium foil also. Iron is also can be changed into sheets. Okay. For example, aluminium metals can be hammered into a thin aluminium foils. Copper metal can also be hammered into a thin copper sheets. Iron is also quite a malleable metal which can be hammered to iron sheets. It is due to the property of malleability that metals can be bent to form objects of different shapes by beating with a hammer. Non-metals are not malleable. They are brittle. If you will take non-metal and beat, it will break. Now you know the nib of the pencil. Nib of the pencil is called as graphite. It is carbon. And carbon is a non-metal. Now if you will hammer that nib of the pencil or pencil, okay, it will not change into a sheet. It will break. So non-metals are brittle. They are non-malleable. So please underline here, carbon is a non-metal. Carbon is found in many forms such as charcoal. You can see in your books if you are unable to see here. Charcoal, graphite, diamond. Diamond and graphite are carbon only. Okay, they are two different forms of carbon where the atoms are arranged in, or electrons, okay, that you will study in higher classes. Electrons are arranged in different way. Coal is also mainly carbon only. The pencil lead is a form of carbon called graphite. If we take a piece of carbon, let us take pencil nib here, and beat it with a hammer, it will break into pieces. We cannot hammer carbon without breaking to obtain a thin sheets of carbon. Thus carbon is a non-metal which is non-malleable. So just remember, non-metals, they are non-malleable. Example you can take of pencil nib, which is a carbon. So if you will beat, it will not change into a sheet, but it will break. So the property to which non-metals break on hammering is called brittleness. Okay. Ductility. What is ductility? Ductility is that when an element is changed into a wire. So metals are ductile. You have seen copper wire. Okay, so metals are ductile. This means that metals can be drawn into thin wires. Copper wire you must have seen, no? Most of the metals are ductile. Gold and silver are among the best ductile metals. So they are malleable also, they are ductile also, they are shining also. That is why they are used to make jewelries. Okay, gold and silver are the best ductile metal. Copper and aluminum metals are also very ductile and can be drawn into thin wires of aluminum and copper. You can see this is a copper wire. So this is ductility. Okay. Iron, magnesium and tungsten metals are also quite ductile and can be drawn into wires. Iron wires are used to make wire gauze. You know this thing. Magnesium wires are used in laboratory, and thin wires of tungsten metals are used for making filaments of an electric bulb. You have seen that. Okay. So please underline the property which allows the metals to be drawn into wire is called as ductility. Generally, metals are malleable and ductile. Students, non-metals are not ductile. Okay. Please underline this. Sulfur and phosphorus, they are the non-metals and generally they are powdery. Okay. So they are not ductile. They cannot be changed into wires. Okay. So please underline, non-metals are neither malleable nor ductile. They are brittle. Conductivity. Metals are good conductors of heat and electricity. Means metals allow the heat and electricity to pass through them easily. If we hold that, you can see, if you hold one end of a metal spoon and a hot water, the other end also becomes hot. This is because the metal of the spoon conducts electricity. Okay, copper, silver, gold, aluminum and iron metals are good conductors of heat. Please underline this. Now what is this? Students, this is a simple experiment, you know, very simple. If suppose this is a candle, if this is any metal, let us say copper wire or copper rod, you can say. Okay, let me say this is a copper rod or copper rod. Here with the help of wax, this pin is fixed and you heat it from this end. After some time you will see the pin from this end will fall down. Why? Because wax will melt and the pin will fall down. So what does it mean? This end gets heated up and this heat, it is transferred from this end to this end, which melts the wax and the pin falls down. Conductivity does not mean that metal is producing heat or metal is producing electricity. It means conductivity that it transfers the heat or electricity from one end to the other end. That is what conductivity means. Okay. So metals are good conductors of heat and electricity. Even aluminum spoon, or even in the morning also, like not morning I'm saying, like even if you keep a spoon in any hot water, okay, you will find that after some time the other end also becomes hot. Why? Because that spoon gets heated up with that hot water and that heat it transfers to the other end. So other end also becomes hot. So copper, silver, gold, aluminum, iron metals are good conductors of heat. Though all the metals are, yes, all the metals are good conductors of heat, but the you can say the level of conductivity, it differs. Okay, understood? Silver metal is the best conductor of heat. Copper metal is better conductor of heat than aluminum metal. So silver is the best conductor of heat. But you know that we use generally copper wires. Okay, the copper wire, generally the vessels are at the base, they are some copper coated. Okay, the bottom is coated with copper. Silver is the best conductor of heat, but it's very costly also. So generally the cooking vessels, they have a copper coating because copper is a good conductor of heat. And when like fry pans and all, and what happens? This metallic bottom, these utensils having the metallic bottom like copper and all, it transfers the heat of the gas stove quickly to the food which is kept inside it, and food gets cooked. Okay, we cannot hold a whole metal pan, definitely we cannot hold directly, because when we keep a metal pan on the gas stove, the heat of the stove, it transfers to the pan Okay, the pan gets heated up from the bottom, but since that pan is made up of a metal, okay, what happens that it transfers the heat of the bottom to whole of the pan, and whole of the pan gets heated up. Okay, so we have so that is why they have a wooden handle, because that wood, that is a bad conductor of heat. So whole of the pan will get heated up, it will transfer the heat, but the heat will not be transferred to the wood. Okay, now metals are also good conductors of electricity, means they allow the electricity to pass through. Now this is, let us say, a battery. This is a copper wire. You know that in electric circuits or electric wiring, copper is used. Silver cannot be used because that is costly. Okay, so copper is used. Okay, now you can see this is connected with a wire, this battery, and the bulb glows. What does it mean? From this battery, the electricity, this battery it is a source of electric current, and this copper wire, it conducts this electric current, or it passes this electric current from the wire to the bulb. Okay, it means this. So this activity shows that metals are good conductors of electricity. But here what they have done, this is fixed with a copper wire, and here there are two clips, this one, and in the middle these two clips are holding a aluminium foil, and you will see that the bulb will glow. So what does it mean? The electricity to the copper wire, it reaches till aluminium foil. Aluminium foil is also metal, so it is allowing this electricity to pass through and reach the bulb, and the bulb glows. Okay, actually without the foil also you can do, because copper is also a metal only. Now if you will remove this aluminium foil, and here if you will place sulfur powder, what will happen? If you will place sulfur powder, you will see the bulb will not glow. So non-metals are not good conductors of electricity. Okay, non-metals are poor conductors of electricity. Non-metals are poor conductors of heat and electricity. Okay, understood? But students, carbon, you know, is a non-metal. So carbon is a poor conductor of heat and electricity because it's a non-metal. But you see here diamond is a non-metal which is a good conductor of heat. What is diamond? Diamond is nothing but it is one form of carbon. So if you know that carbon is a non-metal, so according to that, diamond should be poor conductor of heat. But diamond, so this is an exception. Diamond is a good conductor of heat, and graphite, which is also one form of carbon, it's also a good conductor of electricity. Now you know this experiment. If you want, we can you can do here between if we remove this aluminium foil, and here between these two. Now you take a pencil and sharp the pencil from both the sides and fix this pencil from one end here and another end here. Okay, when you will sharp the pencil from both the sides, this graphite nib will be seen, and both the sides you just fix the that graphite pencil nib. You will see the bulb will glow. But here actually the bulb will not glow. Here you will have to use LED, because you know bulb will glow only when high amount of current is passed through. Okay, so battery may not provide, and so that is why. But if you will use LED, which can glow even with the small amount of current also, so you can use here LED. So when you will or both the sides, when you will fix both the sides of the pencil nib with the clips, the bulb will glow, which shows that graphite is a good conductor of electricity, though it is a non-metal. Okay, so non-metals generally are bad conductors of heat and electricity, except diamond and graphite. Diamond is a good conductor of heat, and graphite is a good conductor of electricity. Another is lustrous. Lustrous means shining, chamak. All the metals are lustrous. When you bring some new metallic vessel or a new copper vessel from the market, it shines. Anything, iron pan, silver, gold, it shines. Definitely with due course of time it loses shine, it becomes dull. That happens because in the atmosphere there are so many gases, like there is the carbon dioxide gas, oxygen gas, okay, nitrogen gas. So these metals slowly they react with these gases, and they also react with the moisture, water, which is present in the form of a water vapor in the atmosphere. Now suppose I am saying this is a copper, let me say. So this is copper, which is a metal. Okay, so this metal will react with the gases present in the air, and some you can say compound is formed, some new substance is formed, and that new substance form a layer over this metal. So what happens again, when you will rub the surface of the metal with a sandpaper, the layer is removed and again the metal starts shining. But what happened here, actually the metal is reacting and some substance or some layer is formed which is of no use. So what happens, the metal, the important or the precious metal is lost. You know that in case of rusting of iron, iron is a metal which reacts with oxygen and water and it forms rust. So rust is of no use, but in formation of rust, the important metal iron is lost. Okay, this I think you all know. So lustrous, if we observe a freshly cut surface of metal, we find that they have a shiny appearance. This is metallic luster, chavak. The shiny appearance of metal makes them useful for making jewelry and decoration pieces. For example, gold and silver are used for making jewelry because they are lustrous, they are malleable, and they are ductile. Non-metals are not lustrous, they are dull except iodine. Iodine is a non-metal having luster. Strength, non-metals are strong, they are very strong. That is why like iron, okay, iron metal is used to make iron metal is used in the construction of bridges, buildings, railway lines, machines, vehicles and chains. Non-metals are not strong, okay. So that is why graphite also simply it breaks on hammering. Sonorous means they produce sound, they produce ringing sound. You know that when the vessels fall, there's some sound is heard, or when the this thing in the temple bell also, when some sound comes. Okay, see here, sonorous means capable of producing ringing sound. If we drop a metal coin or a metal utensil on the floor of a house, we hear a ringing sound. And when a clapper, that is a hammer of an electric bell, strikes the metal gong, even a ringing sound is produced. So the metal objects makes a ringing sound when we drop them on a hard surface or a hard floor. Okay, so they produce a sound, whereas non-metals, they are not sonorous, they do not produce any sound. You can take the case graphite, it will not produce any sound. Hardness metals are generally hard. Okay, it is difficult to cut the metal. Metals cannot be cut easily. Okay, but the hardness of the metal varies. Okay, from one metal to another. For example, if we try to cut a thin sheet of iron metal with a pair of scissors, we will find it very, very difficult to cut, but we can cut aluminium. Okay, so the level of hardness is, varies from metal to metal. Okay, this means aluminium metal is less hard. Okay, that you know. Now, so please underline, sodium and potassium metals are very soft metals which can be easily cut with a knife also. Most of the solid non-metals are soft. Okay, they can be cut with a knife. For example, phosphorus, sulfur, they are non-metals which can be easily cut with knife. Please underline, diamond is a non-metal which is very hard. This is exception. It's the hardest natural substance. Non-metals are soft except diamond. What is diamond? Why diamond is a non-metal? Diamond is carbon, actually it's a form of carbon. Okay, so these are some of the differences which is given. Okay, this you can go through. I will just discuss one or two chemical properties with you. Students, just remember, this is the journal formula. Metals, they react with oxygen to give metal oxide. Just remember this thing. Now, the magnesium. You know all the metals have symbol. So this is the symbol of magnesium when magnesium burns in air. So in air it is burning with what? Oxygen. It gives what? What is the journal formula? Metals, they burn in oxygen to give metal oxides. So magnesium will burn in air to give magnesium oxide. Okay. So this is the equation. Okay. And this is all the metals, they will burn in oxygen to give metal oxides. Now you can see this is a magnesium wire which burns, and it burns with a dazzling light, and one whitish or grey substance is formed, ash is formed, which is actually magnesium oxide. Now this substance or this ash, when you will dissolve in water, okay, it will dissolve in water and it will form a hydroxide. Okay, what is this? See, you just read the journal equations. Metal will burn in oxygen to form metal oxides, Metal oxides, they are actually the basic oxides. Just remember that this metal oxide, okay, this is the metal oxide, see here, this metal oxide will mix in water and it will produce metal hydroxides. They have not given the journal equation, I will write, just see here. You just remember journal equations. Metal, it burns in oxygen to give metal oxides, and metal oxides are basic oxides. These metal oxides, now I told you this magnesium wire will burn in air and it will burn with a dazzling light, but if you will keep some vessel here, some ash is collected and that ash is metal oxide. So when you will mix that ash, or when we mix that ash, or when we dissolve that ash in water, a metal hydroxide is formed, and this ash is basic in nature. Soap is base, soap is a basic. Okay, so please, I am writing only the journal equations. Metal oxides, which is a basic oxide, okay, which is a basic oxide, in water it will give metal hydroxide, and metal hydroxide is base. Base means it will turn red litmus blue. So if I write equation, metal, we will say magnesium, it will burn in oxygen to give magnesium oxide. This magnesium oxide, now this is second one, this magnesium oxide in water will give magnesium hydroxide. See here, understood? And this magnesium oxide is hydroxide is base, and this is basic oxide. Why basic? It is oxide, so we write basic oxide. I hope it is clear. And this is rust. This iron will react with oxygen, it will react with water, okay, in the air, and it will give iron oxide, which is a rust, and this rust is a basic oxide. If you will take this rust, mix in water, what we will get? We will get hydroxide, because that you can check by using litmus paper. It turns red litmus blue. Okay, same way here also, students, that copper vessel, you will see that when you bring a copper vessel, it shines, but with due course of time it becomes, you see that some green coating is formed. So why that green coating is formed? Because this copper, it will react with water vapors present in the air, carbon dioxide gas is also present in the air, and oxygen, okay, and it will form this copper hydroxide, copper carbonate. We call it as basic copper carbonate. Okay, so this is called as corrosion. Corrosion means loss of a metal, because this copper is very important metal. It reacts with this, and over the copper metal or over the copper vessel, like I said, copper vessel loses shine after some time, you can see green coating over it. So that green coating is of this thing. So that green coating is formed, but when you will rub it with a sandpaper, again the copper vessel will shine. But actually what is happening, this important copper is lost, because this green coating consists of this copper also. Okay, so this is called as corrosion. The formation of green coating of a basic copper carbonate on the surface of copper object on exposure to moisture is called corrosion of copper. Just remember, non-metals also react with oxygen to form non-metallic oxides. Now just remember, metal, they react with oxygen to form metallic oxide. Metallic oxides are basic, whereas non-metals also react with oxygen to form a non-metallic oxide, but non-metallic oxides are acidic in nature. So metal oxides in water gives metal hydroxides, which is a base, and non-metallic oxide in water gives what? Acids. See here, non-metal plus oxygen give non-metallic oxides. non-metallic oxides. These non-metallic oxides are acidic oxides. These non-metallic oxides in water will give you, water is this, it will give you acids. Okay, non-metallic oxides are acidic oxides. In water it will give you acids. This blue litmus will turn red. Just remember this thing. Okay, so if a element forms a basic oxide, then the element is, or if a red litmus turns blue, that means that is a hydroxide solution and the metal is and the element is metal. Okay, if the element forms a acidic oxide, then it is a non-metal. Understood? So just do till here, just till here only. Okay, so here this reaction with oxygen whole we will do. Okay, and reaction with water very little I will explain. Students, metals they react with water to form this. Okay, understood? All the metals they react with water to form metallic hydroxide and hydrogen. Just remember, sodium and potassium metals are highly reactive metals. Now sodium and potassium metal, if we keep at a room temperature also, they suddenly catch fire. They are so reactive, they immediately react with oxygen. Why they catch fire? Because in the surroundings air is present, and in air oxygen is there. So the sodium and potassium, they react with that oxygen and they catch fire. Understood? And even in water also, if they are kept in water, the reaction is very, very violent. So sodium and potassium, because they are highly reactive metals, cannot be stored even in open because they will catch fire, and even in water. So generally sodium and potassium metals are stored in oil. Why? Because oil layer is formed over the metals, and that cuts the supply of oxygen as well as the moisture which is present in the air, and metal does not catch fire. Actually it is stored under kerosene oil. Please underline this. Okay, so just remember this thing. So in the next class, okay students, reaction with acids no need to do, reaction with base also no need to do. Okay, now in the next class we will discuss metallic reactivity series, okay, and some uses of metal. So I'll finish the syllabus of term and examination in the next class. If you have any doubt, you can clarify your doubts during live class or during your clarification hour. Okay students, thank you students, have a nice day.